solid, liquid, gas, the three phases of matter. But did you know that there are more states that are very diverse in nature? The first new state is plasma. Plasma is gas that has been heated up a lot. The gas has been heated so much, in fact, that the electrons are able to move around freely. Heat forces particles to vibrate and move quicker. In plasma, the force of motion in electrons overcomes the force of electromagnetism binding them to the atomic nuclei. Free electrons mean that the atomic nuclei are positive ions. This allows plasma to be completely warped by magnetic fields. Stars are hot enough to be plasma. This means that in fusion experiments on Earth, the fusion materials must also be hot enough to be plasma. Since they are plasma, the materials are able to be confined by a magnetic field. This is important because any physical material trying to contain plasma would melt or vaporize. The next phase of matter is degenerate matter. This is a highly pressurized state that exists in the cores of dead stars. There are two known types of this matter and a possible third one. The first is electron-degenerate matter. This type of degenerate matter is the least extreme. I say least because compared to its siblings it is supernormal, but compared to what we're familiar with, it is very odd. Electron-degenerate matter is extremely dense. Water is 1 gram per cubic centimeter, iron is 8 grams per cubic centimeter, and electron-degenerate matter is 2 million grams per cubic centimeter. White dwarf stars are made of this kind of matter. White dwarfs have the mass of a star squished to the size of a planet. Tidal forces around white dwarfs could rip planets apart if they got too close. Electron-degenerate matter is so dense because it is the state where atoms are packed as closely together as possible without being compressed into neutrons through electron capture. Second is neutron-degenerate matter. This type of degenerate matter is even denser than electron-degenerate matter, 100 quadrillion grams per cubic centimeter. This type of matter makes up neutron stars. With this density, the mass of two stars can be packed down to the size of an asteroid. If you fell toward a neutron star, you would be ripped apart before you hit the surface. In neutron-degenerate matter, neutrons are packed as closely together as possible. Any more pressure on the neutrons and the strong force would be overcome by the force of the pressure on top of it. This would break up the neutron into its constituent quarks. Finally is the theoretical quark-degenerate matter. This kind of matter could have different densities based on the size of quarks. Since this matter would be made of quarks packed as closely as they can before breaking down, the size of quarks would affect its density. Also, it is possible that this matter doesn't exist. If quarks are point particles, particles with zero dimensions, then they would collapse into themselves, creating a singularity once neutron degeneracy breaks. A singularity is just a black hole. So if quarks are point particles, then quark-degenerate matter doesn't exist. After this is Bose-Einstein Condensate. Bose-Einstein Condensate is a very dilute gas cooled to nearly absolute zero. This phase of matter occurs when bosons, the carrier particles, become very low in energy, and their waveforms start messing with each other. We can study these interactions to learn more about the quantum world. There is also fermionic condensate. This is similar to the last condensate, but it is fermions, particles that make up our world, that become low in energy. Temperatures close to absolute zero expose the waveform of this kind of matter as well. Another cold phase is superfluid. Superfluid is usually formed by liquid helium because helium's liquid state is right between 1 degree above absolute zero and 4 degrees above absolute zero. Superfluid is a fluid with zero viscosity. Viscosity is what makes syrup and honey flow slowly. Even water has some viscosity. That's why it forms droplets. Without viscosity, superfluid can seep through tiny pores in a material and fall out of its container while water would be held in. Also, superfluid can flow over the side of a container and drip out. Superfluid is able to overcome barriers to get to the lowest energy state possible. This is a good metaphor for quantum tunneling, a topic for another video. This is all the result of having no viscosity. Imagine if water had no viscosity. Holding a cup of it would cause it to just fall out. Thankfully, we have viscosity. Similar to superfluid is supersolid. Supersolid is like a solid without friction. This frictionless state of matter could slide around indefinitely. Finally, we come to the most energetic state of matter, quark-gluon plasma. This phase of matter is so hot that the motion energy of the quarks overcomes the binding energy of the strong force to form a soup of free quarks. The very first moments of the universe involved this state of matter. The entire universe was so hot that this state was the norm. Eventually, the universe cooled down enough for the quarks to form protons and neutrons. This is just a condensed list of all the extra phases of matter there are, and even more are yet to be discovered.